The p-value and the alpha level are interrelated concepts, but there is a slight difference. Alpha value or alpha level is the threshold below which our probability is considered so small that we decided to reject our hypothesis. What does this mean? In our previous slide, we talked about alpha value as our cutoff. That means 5% below is the percentage where we tolerate that the results and its error are not that huge, and so the results are considered to be significant. In other words, an alpha value of 5% is a tolerable value of sampling error. And what's the p-value? The p-value is the actual probability of obtaining the sample data. That means, for example, in your SPSS tables, there is a p-value column there where it provides, for example, a p-value of 0.08. A p-value of 0.08 denotes 80%. And because the value of 80% is larger than our tolerable alpha value, which is 5% or 0.05, that means our result is not significant, or we accept our null hypothesis. So in simple terms, when we talk about P, or the probability value, it is the obtained probability value in our computation. And in our computation, if our p-value is greater than our alpha value, then the result is not significant. An alpha value cutoff is always, at least in social sciences, 0.05. So that means a p-value greater than 0.05 represents non-significant result. A p-value less than 0.05 represents a significant result. So, in terms of creating our hypothesis, there are two tests that we need to refer to, and this is the one-tailed test and the two-tailed test. A two-tailed test is a bidirectional hypothesis statement. In other words, in this hypothesis statement, there is no specific direction. The direction can be right, left, high or low, positive or negative. So there is no specific direction. It can be bidirectional. For example, in talking about a hypothesis on attachment anxiety between males and females, if this is a two-tailed test, then the statement would be there is a difference in the level of attachment anxiety between males and females. Notice that the sentence only talks about having a difference, and there is no direction whether males have high attachment anxiety or females have higher attachment anxiety than males. It's just that it talks about having a difference, and the difference is not being specified. That's what we call a two-tailed test. There is also what we call a one-tailed test. A one-tailed test is a directional hypothesis statement. So, if we restate our hypothesis, we can say females are higher in levels of attachment anxiety than males. That's a one-tailed test hypothesis. However, I have to emphasize, deciding whether you use two-tailed or one-tailed tests in your hypothesis largely depends on your literature. So if the literature says that there is already a direction in terms of comparing the males and females in attachment anxiety, then you do the one-tailed tests. However, if the literature says there are still contrasting results, then you do two-tailed tests. In other words, the literature dictates whether your hypothesis is one-tailed or two-tailed. So please take note of that. Now, remember samples and population? Of course, you do remember, because in the previous parts I've been emphasizing it, that samples only represent the population. And because samples are estimates of population, then there are sampling errors, there is degrees of freedom, and the sampling error is represented by alpha value and p value in terms of deciding whether our results are significant or not. Because of that the samples are only estimates of our population, then it is inevitable that we have errors in our decision making, especially in terms of deciding whether the results are indeed significant or are not. So what are these errors in decision making? These errors are what we call type 1 error, or the alpha error, and type 2 error, or the beta error. Well, in reality, there may be a true null hypothesis. For example, males and females do not differ in terms of their attachment anxiety. And in terms of our decision based on the statistics, we found that really the decision that saying that males and females do not differ in terms of attachment anxiety, therefore that's a correct decision. So here, this is the reality, this is how the population should be, and here, this is our decision. This is our decision based on the results of our statistical computation. Now, there are two most common errors that we commit when we accept or when we reject the hypothesis, whether null or research hypothesis. And these errors are type 1 and type 2 errors. Now, what is type 1 error? Type 1 error denotes that in reality, there is no difference between males and females in terms of attachment anxiety. However, in your results, you decided that males and females differ. So there is now a contrast between what the reality is presenting and what your decision is. So that error in that estimate is what we call alpha error or type 1 error. There are also instances that in reality, males and females differ in their attachment anxiety. And so, because of that, in our decision making, we are able to decide that males and females do not differ. So there is still a contrast, because in reality, males and females differ in attachment anxiety. But in your decision regarding the results of your analysis, you say that males and females do not differ in their attachment anxiety. That error in decision making is what we call type 2 error or beta error. So again, alpha error is an error we commit where we decide that there is a significant result, but in reality, there is no difference. For example, we decide that men and women differ in terms of attachment anxiety, but in reality, men and women do not differ. That is type 1 error. Type 2 error is the idea of saying that men and women do not differ in terms of attachment anxiety, but in reality, men and women differ in terms of attachment anxiety. So that's type 2 error. So how do we reduce type 1 error? The more we make our alpha cutoff strict, the less likely we are to make type 1 error. So instead of saying our cutoff is 0.05 for us to decide that the result is significant, we make it more stringent and make it 0.01. So we only tolerate 1% of error instead of 5%. So that reduces type 1 error. How about type 2 error? How do we reduce it? Type 2 error is for reducing type 2 error, you have to increase the size of sample so that a true population is more likely to be represented. Well, in our decision making in terms of the results based on our statistical techniques, we always commit either alpha or beta error depending on our decision. This is because, as we said, our samples only represent our population. And because they are only representations or estimates of our population, we always have the risk of committing either alpha or beta errors. And this is the risk that we should be thinking of in terms of our results. So there is no absolute result because most of the time, these results have errors with them. So in general, our discussion on the prelude to inferential statistics include sampling errors. Then we went to how sampling errors are being represented in statistics. Then hypothesis. And finally, throughout the discussion, it has to be emphasized that our samples are only estimates of the population. And statistics is there to guide the researcher regarding his or her decision making. The decision maker is still the researcher, and statistics is only a guiding tool to support the researcher's decision.